Okay. So let's look at the first question. All right, look at the first one. First pick, 52nd question. We've got a potential energy graph. How many equilibrium positions you have got? The minima and the maxima are equilibrium positions for a UX graph. All right, that's what we have seen. If I keep a ball over here, exactly over here, it will remain there. If I keep a ball exactly at the topmost point at the apex, vertex, the ball remains there. So that's a equilibrium position. So I've got two equilibrium positions. And look at this. Which of these, the moment I say equilibrium, the next question should be whether it's equilibrium stable, unstable, or neutral. All right. So what do you think it is? See, this point is stable. If I leave a ball here, it stays there. If I disturb it, it returns to the original point, equilibrium point. So it's a stable equilibrium position. At point D, if I disturb this ball, it will go away from the equilibrium. So it's unstable equilibrium point. It will come back to the equilibrium. So that's unstable, this is stable. So he says C point is stable. Yeah, that's right. B and D are equilibrium positions? No. B and D are not equilibrium positions. C and E are equilibrium positions. And then force of interaction. Look at this. The force over here is minus du dx. Slope is negative, so force is positive. F is equal to minus du by dx. This is negative, so force is positive. So force is repulsive in this region. From A to C, the force is repulsive. So that's right. So fourth is right. Option 2 is right. So he's asking which of the above statements are correct. 1 and 3, 1 and 4, 2 and 4, 2 and 3. So answer is already ticked there. It's 2 and 4. I hope you have understood the question. Any doubts?
So,
Yeah.
can you tell me why the option 3 is wrong?
Option 3 is wrong. Yeah. Force of attraction, interaction between two particles is attractive between points C and B. Between C and B, look at this. This region, my force is minus du dx. Whereas du by dx is negative here. So my force is positive, which means it's repulsive.
Yes, sir.
But he says it's attractive. Between A to C, it is repulsive, totally repulsive from A to C. And B and C is a part of A to C, right? If you understand from A to C, you will understand from B to C. He says it's attractive, but A to C is repulsive. And repulsive between points D and E. D and E, यहाँ से यहाँ तक. Look at this. Slope is positive. my force will be negative, which is attractive between two molecules, right? Two atoms. Sorry, it's two atoms or two particles. If the force F is proportional to R, but negative R cap, so it's attractive. It is pulling each other. It's okay, Vignesh. Vignesh, is it okay?
Yes, sir.
Okay. Let's look at the next one. The velocity time graph of a particle is given. Mass is 2 kgs. Work done by all the forces between time intervals is given. 0 to 10 seconds. So work done by all the forces is nothing but change in kinetic energy. Work done by all the forces is nothing but change in kinetic energy. What is change in kinetic energy? Half m v final square minus half m v initial square. So half m v final square minus v initial square. M and 2 gets cancelled out because m is 2 kgs. V final ఎంత ఉంది 20 square minus 10 square. That is 300 joules. Work done by all the forces is changing kinetic energy. Speed is increased. So speed is increased means kinetic energy is increased. So energy is injected into the system. So work is done on the system, on the particle by the external force. That is why energy is increased. Kinetic energy is increased. Work is not leaked out. Work is injected into the particle. Energy is injected, not a work. Energy is injected, so work is done on the particle. All right. How do I get 20 and 10 from graph? This is minus 20. This is plus 10. So speed over here is 20. Speed over here is 10. So V final speed is 20. V initial speed is 10. So half m 20 square minus half m 10 square. M is equal to 2 kg. So half and m get cancelled out. So 20 square minus 10 square, which is 400 minus 100, which is equal to 300 joules. All right, let's go for the next one. 20th question, third pick. Conserve energy at the 2 points. Conserve mechanical energy. Total potential plus total energy. Potential plus kinetic is equal to potential plus kinetic at 2 points. Point A and point B, let's say. Yeah, point A and point C. He's talking about point C. So let's conserve energy from point A to point C. I mean, at point A and point C. Energy is captured. Energy is not dissipated. It's frictionless, he said. This is 14. This is 5. This is 7. This is C. This is B. This is A. So I'll have mg into h2 minus h1 released from rest. So initial kinetic energy is 0. Work done by mg. There are two ways of doing it. I mean, two approaches to it. Work done by mg is work done means mg into h2 minus h1 is delta ke, which is equal to half mv square, vc square. This is one way of doing it. Or I can also write mg into h2 plus half mva square is equal to mg into h1 plus half mvc square. Both will give me the same answer. In fact, mathematically they are same. But this says work done by mg, external forces is equal to change in kinetic energy, and this conservation of mechanical energy. Initial potential plus initial kinetic is equal to final potential plus final kinetic when there is no dissipation of energy. All right. This is 0 anyway. This comes here, it becomes h2 minus h1 is equal to half mvc square, which is same as the above equation. So whether you use this concept or this concept, you will arrive at the same answer. It is good to think in both the directions while practicing. In exam, you will apply only one. Let's say there is friction as well. Then you'll go for, you will also add friction in it, friction component, and get the answer. Okay, so what's the answer for this one? Mg into 14 minus 7. Half mv square, m gets cancelled out. So g into 7 is equal to half times vc square, which is equal to, he's asking kinetic energy, right? So I need mgh. Mg into 7. Mn only 2 kgs. So how much is this? 20 into 7, which is 140 joules. 140 joules is the energy at this point, kinetic energy at this point. How do we get that? This potential energy is being converted to this additional potential energy over here. If I take this as a reference, this additional potential energy over here is being converted to kinetic energy over here. So what is it? Mg into 14 minus 7. So Mg into 7. 2 into 10 into 7. 20 into 7, 140. 140 is being converted to kinetic energy over there.
So,
Yeah.
if you don't mind, can you explain once again? We don't get what you had said, sir.
All right. All right. I'll explain it. Not a problem. You're able to hear me? Is the network fine? You're able to hear me, Vignesh?
Yes, sir.
Okay. See, all I meant to say is, I take this as reference level, or I take this as reference level. I take some reference level because I told you whenever you write potential energy, you need a reference level. And whenever you're taking gravitational potential energy, you'll take some horizontal level as reference level. So if this is my reference level, what's the initial potential energy over here? Mg into 14, right? 14 meters high. Plus kinetic energy is 0, released from rest. What is the potential energy over there at the end? Mg into 7 plus kinetic energy at C. That is what is required. So kinetic energy at C is equal to mg into 14 minus 7, which is equal to 7 mg, which is equal to 7 to 14, 14 times 10 is 140. 140 joules is the answer. That's what I'm telling. This is conservation of mechanical energy. I could also do it this way. Mg is doing work. There is no other work done. Friction work is 0. Normal reaction doesn't do any work because it's perpendicular to the motion. Mg into h2 minus h1 is change in kinetic energy. Initial kinetic energy is 0. Final kinetic energy is mg into h2 minus h1, which is mg into 14 minus 7. 7 mg, which is 140. Is it okay, Vignesh?
Yes, sir. Thank you, sir.
Most welcome. No problem. Okay, look at the 8th pick, 50th question. Eighth pick. They are dropping by the same height h. So change in gravitational potential energy is same. Work done by mg is same in both the cases. If work done is same, change in kinetic energy is same. Two identical blocks he says. So masses are same. So change in kinetic energy is same. Work done by all the forces is change in kinetic. Work done by mg in both the cases same. mg into h, mg into h. Yeah, think about this question. It's a good question. Yeah, so how do you do this? Which option is correct? Only statement 1 is true. Statement 2 is true. Statement 3 I'll tell you, but statement 1 and 2. You tell me about statement 1 and 2. Kinetic energies have to be same because work done by mg is same. So statement 1 is wrong. Statement 2, acceleration he says of a is greater. What decides the acceleration? The angle of the wedge, angle of inclination of the wedge. Mg sine theta. Theta is more, sine theta is more, so acceleration is more. So acceleration of A is more than that of B. So that is true. How about 3? Work done by external agent is negative, he says. Work done by external agent around on the it's coming down. My work done by external agent is applying force opposite to the direction of mg sine theta. To bring it slowly, net force should be zero. Applied gravitational force is downward, down the plane. So applied force should be up the plane. Displacement is down the plane. So force is up the plane. Angle between them is 180. They are anti-parallel. So work done is negative. So statement 3 is correct. Statement 2 is correct. Statement 1 is incorrect. Okay, look at the ninth pick, 55th question. 55. Question number 55. You're all NEET and mains level question students. This especially is NEET level 55. Similar question. Change in function has appeared in NEET many a times. So u of xy cos x plus cos y. I know that f is equal to minus del u, which is equal to minus du dx I cap minus du dy j cap minus du dz k cap. Now substitute u over here. So f is equal to minus d du d dx cos of x plus y I cap minus d dx cos of x plus y j cap. Anyway, with respect to z, it is 0 because x and y are constants. So with respect to z, that is 0. So all I have to do is just differentiate this with respect to x and y, partially differentiate with respect to x and y. When I differentiate this function partially with respect to z, x and y are constants. So cos of some constant, which is a constant, 0. All right, I'll plot such functions and show it to you one day. All right, as of now, just do it mathematically. Graphically, we'll see it later. Okay, solve it further. Differentiate cos of x plus y with respect to x, partially with respect to x. So y is remaining as constant. So I'll have derivative of cos is what's derivative of cos?
Minus sign.
Minus sign, sir.
Okay, so that becomes sine of x plus y I cap plus sine of x plus y j cap at a point 0 comma pi by 4. So I substitute x as 0, y as pi by 4. So what do I get? Sine of pi by 4. Sine of pi by 4 is nothing but 1 by root 2 I cap plus 1 by root 2 j cap. So that's my force at a point 0 and 0 comma pi by 4. X comma y as 0 comma pi by 4. Is it clear? Said minus sign, but minus into minus becomes plus. So I've got sine of x plus y I cap, sine of x plus y j cap. X is 0, y is pi by 4. So sine of pi by 4 I cap plus sine of pi by 4 j cap. Sine pi by 4 is 1 by root 2, sine 45. 1 by root 2, 1 by root 2 I cap plus 1 by root 2 j cap. Okay, look at the sixth pick now. Sixth pick is a good question, mains level question. Need students, this could be a combination of questions. If you split this question into two questions, you'll get neat question. All right, so mains is not that different from neat in terms of concepts, difficulty of concepts. Numerically, it could be different, little difficult, but conceptually, they're on the same level. Sixth pick, 46th question. In that, tell me what is the relation between velocities of A and B? Tell me the constant equation. What is the relation between velocities of A and B? If velocity of B is V naught, what is the velocity of A? When speed of B is V naught, what is the speed of A? So look at the question and tell me, look at the diagram and tell me what is the speed relation between speed of A and B?
So is it V by 2?
Yeah, no, it's not V by 2. Yeah, Bhavana, we cannot substitute x and y directly. We have to differentiate first because he says we need to find force acting on the particle. He is not asking potential energy of the particle. We need to find the force acting on the particle. From potential energy function, I have to get the force, which is F is equal to minus del U or minus du by dx for one dimension. For three dimensions, it's minus del U. So from after getting force, then I substitute the point. Okay. So this question, it is not V by 2. Think again. Velocity of B is V naught. What is the velocity of? What is the velocity of A? This angle is 37. This comes down by 5 meters. Mass of A is 5. Mass of B is 4. 4 kgs, 5 kgs. So this comes down to a vertical depth of vertical distance of 3 towards 37 degrees, 3, 4, and 5. This block comes down the incline by 5 meters. That means it comes down by a vertical distance of 3 meters. So work done, if that comes down by 5 down the plane, how much does this particle go up? Simply based on constant motion, students. If this goes up by x, that comes by yeah, Bhavna,
2x.
your turn. Yes, 2x. That's exactly right. So if it comes down by 5, this goes up by 2.5, 5 by 2. And this is V naught, that is 2 V naught.
So that's what I had said. So
You said V by 2. I told you what this velocity is V naught. You told me V by 2.
oh, okay, sir. I've taken the A block and find out the B block.
Oh, but I gave you V naught is B.
Okay, sir, that's my fault.
No, that's okay. That's a look and say. I mean, the moment you look at it, you should get the thought. That's the point which I'm trying to convey. It's a look and say. All right. Anyways, he says B travels down a distance of 1 meter along the incline. All right. Question he says 1 meter. Diagram he says 5 meters. All right. Let's take some x naught meters. All right. So this will be or 5x naught meters. This will be 3x naught down the plane. This will go up by 5x naught by 2. So what is the change in potential energies of the system? Five kg, 5g into 3x naught minus 4g into 5x naught by 2 is equal to change in kinetic energy of the system. Initially, it starts from rest. System is reaching some rest. So final kinetic energy is half 5 2v naught square plus half 4 V naught square. He's asking V naught. Solve for this, you'll get V naught. That's it. Remaining is just simple math. But why did I choose 2 V naught and V naught here? He's asking for V naught. I took this as V naught. So this will be 2 V naught. So kinetic energy will be half m V1 square plus half m to V2 square. Half 5 into 2 V naught square, because the speed of that is 2 V naught. Speed of this is V naught. So half 4 into V naught square. So I got the kinetic energy of the system. Delta K, this is final kinetic energy. Minus initial kinetic energy is 0. Minus 0. So work done by all the forces is change kinetic energy. Or drop in potential energy is gain in kinetic energy. All right, that's it. Solve for this, you'll get it. You try this. Let's look at the fourth pick. Okay, little difficult one. Fourth pick, 20th question. Are you all trying the DPP which I sent? Kinematics? Find theta from where this should be released such that it should get lifted up. But the question is, why will it get lifted up? Why do you think that will get lifted up? Let us say it's just hanging like this here. This is 3 kg, 6 kg. So this is more than this. This will be pulled down. Because of normal reaction, it will counterbalance, so it will stay there. But if I release it from here, it will gain some energy. By the time it comes here, it will gain some speed here. Let's say that speed is V naught. Because of the speed, the centripetal force over here will also be increased. Because centripetal acceleration is increased V square by R. So tension will increase. That tension, increased tension, will try to pull that block up. So for this to get lifted up, the tension over here should be equal to 6G. That means tension in the same string, 6G, it should be 6G here. So you all understand what I'm trying to say? This block, as it comes down, will gain some energy. Loss in potential energy is gain in kinetic energy. There is gain in kinetic energy, that means there is some gain in speed. Because of speed, if I do it from ground frame, my tension is the responsible centripetal force there. If speed is more, centripetal force required for it to make the same turn is more. So tension will increase. There is an increase in tension. This increase in tension is being responsible for the for the block to be lifted here. For this to be lifted, normal reaction should be 0. For normal reaction to be 0, my tension should be 6G. If tension is 6G, I'll write the equation over here. T minus mg is equal to mv square by r. This should be 6G minus mg. What is mg? 3G. Is equal to mv square by r. Where is m? M is 3. So 3G is equal to 3v square by r. So all I have to do is plug in v square. How will you get V square from energy conservation? Let this be theta. Drop in potential energy is 3g into r minus r cos theta. Now that is equal to half mv square, half 3 into v square. So 3 gets cancelled out. Now I want 3v square, right? I'll keep 3 like that itself. I take r common, divide by r here. I take this 2 here. This becomes 6. I substitute this over here. 3v square by r is 3v square by r, substitute as 6g into 1 minus 1 cos theta. So 3g is equal to 6g into 1 minus 1 cos theta. This gets twice. So I'll have 2. So 1 by 2 is equal to 1 minus cos theta. Cos theta is equal to 1 by 2. Theta is equal to 60 degrees. Do you get the logic? That means if I leave it from an angle of 30 degrees or 45 degrees or 53 degrees or any angle which is less than 60, this block will not get lifted up. But at 60, this block will just get lifted up. Why do I say just get lifted up? Because normal reaction just becomes 0 then. If I release from any angle more than that, this will get lifted up before it reaches the bottom. Before this 3 kg ball reaches the bottom, this block will get lifted up.
Sir,
Yeah.
after this class, I will share a video, sir, about the centripetal force only.
Okay.
Can you tell me that it's related to this question also?
All right. All right. All right.
I mean, it is like a practical, not the sum problem, sir.
Okay. Okay. Great. All right. All right. Have you understood this question?
Yes, sir.
Or you share it to me now itself? I'll check if it is very I'll share it to others also. I'll share it in the group.
Sir, I think I should be download, sir.
All right.
I
All
should.
right. All right. You share it after the class. I'll share it in the group.
Okay, sir.
Thank you, Vignesh.
That's not mean, sir. I mean, day before yesterday, I've seen that video,
Mhm.
and now today that video is related to this question. That's why I'm asking.
Okay. Okay. All right. Good. Good. All right. I'll write the equations in terms of M1 and M2. Otherwise, all right. I'll just quickly write the equations in terms of M1 and M2 because numbers are really confusing. Let's say this is M0 and this is M. All right. M0 is the block which is not moving, which is to be lifted up. And this is M. So for the block to be lifted up, my tension should be equal to M0 G. All right. Now, in this circular motion scenario, vertical circular motion scenario, my tension equation at this point from ground frame, if I draw the FBD, I'll have equation of motion to be T minus mg is equal to mv square by r. I substitute this T naught over here, T here, that will be m naught minus m into g is equal to mv square by r. How do I get this from force equation? Now energy equation. This is force on that block, m naught kg block. This is force on the circular vertical circulation bob, which is executing vertical circular motion. From force equation, I get this. Now energy equation. Mg into r minus r cos theta. Why is it r minus r cos theta? This is r. This is r cos theta. So this remains r minus r cos theta. Mg into h, drop in potential energy, is gain in kinetic energy, half m v naught square. Required mv naught square by r. So I'll take r common from here. Send this 2 over here. Plug in here. So I'll have m naught minus m into g is equal to mv square by r is nothing but 2mg into 1 minus cos theta. G gets cancelled out. So 1 minus cos theta will be equal to m naught minus m by 2m. So cos theta is equal to 1 minus, so 2m minus m naught minus m is m minus m naught by 1 minus of this, right? So 1 matlab 2m. 2m matlab 2m minus 3m. 3m minus m naught by 2m. So theta is cos inverse of this. Is it correct? 1 minus of this one is this much, sir, right? Check.
Sir, I
I could
think,
be wrong. I could be wrong here. Check.
yeah, sir, it could be m minus m naught by 2m.
Acha. 1 minus m naught minus m by 2m. So take LCM. 2m minus of this one by 2m. Minus of minus plus 3m minus m naught. Correct. Yeah, correct, no?
Yes, sir.
Okay. If I plug in m as 3 and m naught as 2, sorry, m naught as 6, did I get the answer? 3 by 6, which is 1 by 2. Yeah, I'm getting it. Cos theta is 1 by 2, theta is cos inverse of 1 by 2, 60 degrees. Alright, but exam, you have to do it the way he has given. 3 kg, 6 kg, తీసుకొని solve చేసుకోవడమే. Alright, just for explanation, I've done it in symbolic form. But exam gives you numericals, go ahead with numericals itself. Aspect, 83rd question. Stop with that. And students, tomorrow you don't have class. It's holiday tomorrow. On Sunday, you have got a class. Chemistry class by Deepa Shri ma'am. 7:30 to 9 in the evening.
Okay, sir.
Right? Tomorrow you don't have class. It's holiday tomorrow. Sunday you have a class from 7:30 to 9 p.m. Okay, now I've got a pendulum. Alpha. There's a pin here. Because of which this comes till here and this becomes the center. Say this is small l, I'll write it as x. This is capital L, L naught. Alright, if I write small l, my handwriting is really bad, I'll write it as x or x naught. And this would be L naught minus x naught. This is theta. Required to find theta. Look at the students, you have to understand one thing, that if it is released from here, this will released from here at a point which is below this point, it will exactly come to this level and stop. That's what you have to understand. This was asked in previous IISc, previous KVPY paper, previous Olympiad paper. Sorry, KVPY paper. Okay, not exactly this, simpler than this. He just asked to what level will this reach. So if it reach to the same level, you have to find the angle over here. So how do I find the angle? I equate this. Here, this vertical should be same. So L naught minus x cos theta should be equal to this minus this, right? So L naught minus x naught cos theta should be equal to total length is L, or this length is how much? L naught minus x naught. L naught minus x naught minus L naught cos alpha, required to find theta. So I'll have theta is equal to cos inverse of L naught minus x naught minus L naught cos alpha by L naught minus x naught. Now substitute x naught as L, small l. That's what the answer is. Oh, sorry, this is wrong. This is wrong. This is wrong. LHS is right. RHS is wrong. Sorry. Look at this. Total length is L naught minus x naught minus L naught minus x naught cos alpha. See, I want to equate this one here. So L naught minus x naught cos theta, required to find theta, is equal to total is L minus x naught. I got this one minus this one. How much is this? This is L minus L cos theta. L minus L cos alpha. So L and L get cancelled out. Minus into minus become plus. L naught cos alpha minus x naught by L naught minus x naught is my cos theta. So cos inverse of this is theta. Simple geometry problem, geometry based problem. The only physics fact I've used is if I release it from here at this level, at this potential level, at this potential energy level, it will exactly reach to this level and stop. All right, it will not go above that or below that because it has to reach the same potential energy level. If I take this as reference level, if energy is, let's say, this is h, mgh naught, that should final energy should also be mgh naught. That will happen only again at the same level, same height. All right, if this were accelerating, this things should be different. All right, then this will be tilted. Then you will have to find tilted angle. That will do it for when only MPC students are there. All right, we have got a couple of IPC students right now. All right, students, that's it. Have you understood this question?
Yes, sir.
All right, I committed a mistake initially, so ignore that statement, that equation. I have rewritten it. L naught minus x naught cos theta is this much. I have to equate this from this side and this side. This side is L naught minus x cos theta. In terms of alpha, it would be L naught minus x naught minus this one. And this one is L naught minus x naught, L naught cos alpha. L naught gets cancelled out, then remaining is a simple math. The only physics fact which I've used is it will reach to the same potential energy level, reach to the same height. All right, because my horizontal level is my equipotential energy level, it will reach to the same horizontal height, same horizontal position again when it stops again. All right, students, tomorrow you don't have class. You got class on Sunday, 7:30 p.m. to 9 p.m. Bye, everyone.
Bye.
And Vignesh, you said you'll send something, na? You please do send. All right, don't forget.
No, sir, I will.
All right, thank you, Vignesh. Bye, everyone.